So I've got a question for us here about the equations of the tangent lines. Now, it may seem a little weird to talk about equations, plural, when we're talking about tangent lines, but there's actually going to be two different points of tangency here. So to see what's going on, let's start with a picture, right? I'm going to sketch a graph of the function. And we have the point 0, -4 down there on the lower end of the y-axis. So there are going to be two tangent lines coming up through that point. So that's why we're going to get two answers here. Now, to do this, we're going to kind of rely on the symmetry. It's fortunate that the point we were given to work with is on the axis of symmetry of the graph, because I'm going to let A be the x-coordinate of the point of tangency of the right-hand tangent line, and because of the graph's symmetry, this point over here is going to be negative A. All right, and that means that the y-coordinates for both of those points is going to be a squared plus 1. So we're looking at the points a comma a squared plus 1 and negative a comma a squared plus 1. Right, and that's important, right? Because we're trying to find the equation of a line. To find the equation of a line, we need to know the coordinates of a point on the line. Right, so those are the points we're going to use. Now hold on to those. Right, hold on to those. We're going to dig into the calculus part of this for a little bit. We're going to start with the function, right? And I'm going to find the derivative of the function because we need the slope of the tangent line. Right, so the derivative of x squared is 2x. The derivative of 1 is 0. So f prime is going to be just 2x. And if I take my first point, if we do the x equals a tangent point, then the slope is going to be 2a. And remember, we already had that point, a comma a squared plus 1. So if I put the coordinates of that point and 2a for the slope into the point slope equation, we get this thing. Okay, I mean, that's good as far as it goes. But now I'm going to just do a little algebra, right? Play around with this, solve it for y. Right, put it into the slope-intercept form, which is the form we usually want the equation of a line in. Okay, so that's the first tangent line. Now let's do it for the second one. Right, I'm going to put negative a and a squared plus 1 for the coordinates of the point. And now we're going to have negative 2a for the slope. So if I put those points into here, we get this equation. And again, I'm just going to do a little algebra, right? Clean this up a little bit, solve it for y, and we get this equation for the slope-intercept version. Okay, so that's nice. We've got two equations, okay, but I don't want those a's floating around in there. I just want x, y's, and numbers, right? So this is where that point that we know, that point 0, -4, is going to come into this, right? That point satisfies both of those equations. So I'm going to take that point, and I'm going to substitute 0 and -4 into the second equation here, the negative 2ax1. It doesn't matter which one I pick. And you're welcome to confirm this. We're going to get the same numbers either way. Now, if we manipulate this a little bit, clean it up, that negative 2a times 0 is 0. We'll rearrange the terms a little bit, move the a over to the left. This becomes a squared equals 5. Then we'll take the square root of both sides, and we get a equals plus or minus the square root of 5. And that's great because it's exactly what we expected, right? It matches kind of the geometric model we had on the previous slide where we had plus a on one side and minus a on the other side. Excellent. Okay, but we haven't quite answered the question yet. To get to the final answer, I need to take plus square root of 5 and put it into the first equation. Right? And if I do that, it becomes this. And I'm also going to take the square root of 5 and put it into the second equation. The minus part is built in. Right? When I did 2 times minus a and x minus a, the minus part was kind of built in already. So I'm just going to put plus square root of 5 in there again. And we get this equation. And you see that the slopes do match what we get for our values, for our two values of a from the derivative, and both of those lines do go through the point 0, -4. So those are going to be our two solutions. So if you'd like to see the context, if you'd like to see the lecture that preceded this, you can click on the link below. It'll take you over to there. And if you like this video, please don't forget to click on the like button down below.